So hi everyone, welcome to our channel, and our today's problem is count lucky permutations. So what is the question? You are given an array of integers of n elements, and which is a non-weighted undirected graph having n nodes and images. The details of each edge in the graph is given to you in the example what I will explain you. And an array permutations is said to be lucky if for every node, okay, pi, where I means I will be greater than 1 and less than n minus 1 in the array, there exists an edge between the nodes bi and I plus 1 in the graph. Okay, so what is the input and output? Okay, so here suppose n is there, means the size of the array, two edges is there, so m equals to 2, array is 1 2 3, and graph is your 3 comma 1 1 comma 2. So there should be an edge between 3 and 1 and 1 and 2. So output is 2 here, like two permutations can be there for this given array elements. So for 1, 2 and 3, the first combination is 1, 2, 3. You make 2 as root, 1 as one edge, 3 as another edge. So this edge is present, which is this one, but this is not present. So this permutation not accepted. The second one is 2, 1, 3, and here you will make 1 as root, 2 as one edge or child, and 3 is another. As this is undirected, so there should be no edge. Okay, so here 2 and 1 edge is there, 1 and 3 edge is there, so this will be accepted one. So this is one good permutations. Okay, the next one is 3 1 2. Okay, so again 1 is edge here, sorry, 1 is root here, 3 is one edge, 2 is another edge. So this is accepted, this is accepted, so this is also acceptable. So these are the two proper permutations. So the output is 2 here. Okay, so now I will explain you what I have done. So basically a class solution is defined, and a method lucky permutations is created, which takes 4 parameters n, m, r, and 2D graph. Okay, so after that, a 2D array dp of long data type and a 2D array of adj, which is int data types, are defined here. After that, what I've done, so a for loop iterates from the 0 to n minus 1 and assigns the value of 1 to the element at the position, okay, position I and j in the dp array. So here also, okay, so where j is the binary representations of one then a bitwise means signed left operator, okay, which is 1 less I, means this one. Okay, means this meaning, this is signed left operator. So after that, another for loop iterates from the 0 to m minus 1 and assigns the value of 1 to the element at positions graph I 0, okay, minus 1, and graph I 1 minus 1. Clear? So if you will have any questions, you can comment below. Okay, yeah. And also for the same, for the graph uh, I1 minus 1 and graph I0 minus 1, I have set 1 for both. Okay, then here what I've done, a nested for loop iterates over the bit mask I and j, and if the bit mask at the ith position is set and the value at j is not equal to the value at I, and if the value at j is not equal to the value at I, and the value at r of j is also set, and the value of the element at position r I minus 1 as j minus 1 in the adjacent array is 1, then the value of dpi bit mask, okay, is incremented by dp j of bit mask pow this signed one, means I left signed operator I. Okay. After that, a variable answer is declared with an initial value of 0. Okay. And the for loop, what I have done here, the for loop iterates from the 0 to n minus 1 and adds the value of dpi 1. This bit was signed left operator in minus 1 to answer. Okay. So I am after finally the method returns the value of the answer. So it's a little means it's little hard problem, you can say. So you can means you also try to understand and practice more and more for a better understanding. And if you have done any another approach, then you can obviously comment below. Okay. So thanks for watching. Keep coding, keep practicing, and stay tuned. Thanks.